All right, we're back. We're on page 2 of note 7 of Calc C. We're talking about the ratio test, eventually the root test. I am of the opinion that the ratio test is the best test ever. You use it a lot. It's kind of fun because you get to simplify things. Applicable in all kinds of circumstances. So like it's my go-to. I always hope that I can use it. So ratio test, best test ever. Here's what it says. For the sum of a sub n with a sub n not equal to 0, because if a sub n is always 0, like what are you even doing? We're going to let rho, so this is RHO. Can I even draw one of those? I don't know. It's like a P. This is RHO, Greek letter, basically a P. I think a lot of people just make a P out of it. Some people just use R because like, why not? We're going to let rho be the limit as n approaches infinity, the absolute value. So notice absolute value, which means you could have positive terms, negative terms. Ratio test doesn't care. Absolute value, a sub n plus 1 divided by a sub n. That's why it's called the ratio test. You find the ratio of consecutive terms, right? If a sub n is your term, then a sub n plus 1 is the term after it. It's the ratio of consecutive terms. Very geometric. Feels like a geometric type thing. So we're going to let rho, or r, or the ratio, be the limit as n approaches infinity, the absolute value a sub n plus 1 over a sub n. Then the series does the following. Converges if rho, the ratio that you found, is less than 1. Feels geometric. Diverges if rho is greater than 1. Feels very geometric. Test is inconclusive if rho is equal to 1. Not super geometric, because for geometric, definitely diverges if the ratio is equal to 1, because it's not really geometric at that point. But so converges if rho is less than 1, diverges if rho is greater than 1, inconclusive if rho is 1. It just means use a different test. And we know a lot of other tests, so you're going to have to just fall back on those. This is a big deal. So the fact that you use absolute value means that like you could have a negative 1 to the n in there. It doesn't make a difference. The fact that the conclusions are really similar to geometric is nice because we already know those conclusions. And so let's see if we can do this. So we're going to use it. Number one hint on when to use the ratio test pretty much is if there are factorials. If you see factorials, ratio test is like almost always the way to go. So here, this is giving me, so I don't usually write this out, but I'm going to do it this time. A sub n is n factorial squared over 3n factorial. All right, so now maybe you see why we were doing the first page where we're simplifying these. We're going to say that rho is the limit as n approaches infinity. We should put absolute value, so I'm going to, but like, you know, you don't need it. So the n plus first term is going to be quantity n plus 1 factorial squared. You got to be careful with that. It's n plus 1 factorial and then square it over quantity 3 times n plus 1. So I'm just going to write 3n plus 3 because it seems easier. Now, you're supposed to do the nth term, the n plus first term divided by the nth term. In practice, what you really end up doing is the n plus first term times the reciprocal of the nth term. So instead of like doing a fraction here, I'm going to say, well, I mean, it's still a fraction. I'm going to say times the reciprocal of this. And that's how I do it every time. And I think that's like really standard. N factorial squared. Okay, so now we got to simplify this. I'm going to do a limit as n approaches infinity. You can drop the absolute value at this point because everything's positive, so it doesn't actually make a difference. Let's peel off, right? So similar looking things. I'm comparing this, and then I'm going to work on this and this. So like you have to decide like what are we dealing with? So I'm going to say this is n plus 1 squared and then n factorial squared, right? So I peel off an n plus 1, I square it. What am I left with? N factorial and then squared. So those are going to cancel. And then here, there's still a 3n factorial because it's the smaller one. You're always peeling off the bigger one. So n plus 1 is obviously bigger than n. 3n plus 3 is pretty obviously bigger than 3n factorial. So peel 3n plus 1. Nope. 3n plus 3. 3n plus 2. 3n plus 1. That's annoying. And then 3n factorial, and then there's still an n factorial squared, Ugh. All right, so what goes? U and U. I mean, that was the whole premise, was that we were gonna like find things that cancel, and then U and U. And so we are left with the limit as n approaches infinity. So I like typically would show almost none of this work. And I will, this is basically what I would have written, I think, this step. I would have jumped right here. Because you just know, like through experience, what's gonna cancel. So I think you can jump right to here. And then we have a quadratic over a cubic. So this limit is definitely 0. And then 0 is, whoa, is less than 1. Therefore, our series, did I expect that to happen? I don't know. 3n factorial, n factorial squared, n plus 1. I guess so. I don't think I expected that, but like that's what's happening. N factorial squared over 3n factorial, and probably from 1 to infinity. Nope, 0, because 0 factorial is 1, so that's okay. Converges because we got something less than 1. So let me just take a second here. I think I'm going to do like all of these. But let me take a second and just show you on the calculator. So we can work on these on our calculator. So what I'm going to do is I'm going to define a sub n as the quantity n factorial. Factorial is in the question mark. Press the question mark twice and then enter there. And then quantity 3n factorial. Ooh, no, denominator factorial. And then, so you have like a lot you can do. You can do a of n plus, I don't actually know what'll happen here. Do this. Okay, so it gives me this. I don't know. I'm gonna take the limit. So I want the limit as n goes to infinity of the answer, and it gives me 0. So like the calculator can do it. So when you need it to, go for the calculator, let it check it for you, or like maybe just do the ratio test for you, whichever one you prefer. Well, I mean, it's probably not up to you. All right, this, I'm going to say, like, there's no way. The limit as n approaches infinity of this is definitely infinity. There's no way this converges, but let's do the work anyway. So we're going to say rho is the limit as n approaches infinity. Absolute value, 2n. So I'm doing n plus 1, right? So that's 2 times n plus 1 is 2n plus 2. Factorial quantity n plus 1 to the 5th times the reciprocal, n to the 5th. 2n factorial. Okay, so what does this give us? The limit as n approaches infinity. Again, I can drop the absolute value because everything is positive. I'm going to have 2n plus 2, 2n plus 1, and then there's still an n to the 5th over the quantity n plus 1 to the 5th. All right, so just think it through. This is a 7th degree polynomial divided by a 5th degree polynomial. 7th degree polynomial is going to win. You like L'Hopital's, you can, there's a lot of options. This is infinity, which is definitely greater than 1. Therefore, we can say that 0 to infinity, the quantity, I think it was 2n factorial over 5 to the n. No, n to the 5th. 5 to the n is also going to diverge, but n to the 5th diverges. And that is the ratio. That's the beauty of the ratio test. Like it's super compact. It falls back on a little bit of algebra, but like who's afraid of algebra, you know? All right, let's try this. So this is a P series that converges. So like we already know, right? P is equal to 3, 3 is greater than 1, this converges. But let's try the ratio test. I'm gonna do the limit as n approaches infinity of n plus first times the reciprocal, which is n cubed over 1. All right, but if I take this limit, I get 1. Inconclusive. So ratio test. Give me, okay, test inconclusive. So we need to use another test, but I mean, we already knew that it converged. P series, P is equal to 3, definitely converges. But this is a good fact to know. If I try to use the ratio test on a P series, which is the wrong test, like you shouldn't be using a ratio test on a P series, just like think about what's going to happen. you always end up with the same degree polynomial, or the same the same degree power function, over the same degree power function. You always get one, always. So P series is always going to be inconclusive. Therefore, inconclusive. Like this is a P series. P, oh, rho versus P, that's confusing. P is 1/2, less than 1, diverges. This was a P series. P is 3 greater than 1, converges. So if it's a P series, do not waste your time. And I'm going to end it here. So we did 2 where it made sense to use it. There's really only 1 where it made sense to use it, because this one, the nth term test for divergence, told us that it diverged. This one, I don't know. Actually, that one I got a result that I found a little surprising. And then P series, don't bother. It's not always the right test. It's just when it is the right test, then is it good. All right, so I'm going to stop this here. I'll be back in the next video, and we'll keep going. So see you there.